Okay, so I wanted to pick up where we left off in class today about talking about our definition one and using that to find our slope of our tangent line. So we talked about how if we're given a function and we're given a specific point, we can go ahead and instead of doing all of the work with the f of a, we can go ahead and calculate what the f of 2 is and then use it in our function. So we know that our goal is to get this in simplest form. And try to actually substitute in the 2 using direct substitution. But we can see that here, if we try to substitute in the 2, that'll give us a 0 in the denominator, which is undefined, which we don't want. So we're going to have to do a little bit more work up here with this top part. So I'm going to rewrite this as f prime of 2 is equal to the limit as x is approaching 2 of x cubed minus x squared minus 5x plus 6 all over x minus 2. So we're obviously noticing that nothing's going to be canceling with the numerator and the denominator, so we're going to need to do a little bit of work with the numerator. So usually when there's a 4-term polynomial, I try factoring by grouping. So I'll group the first 2 terms together and the last 2 terms together and try to factor that way. This time that's not going to work for us. We're not going to end up getting anything that's in common between these first 2 terms and the last 2 terms. So my other option is to break down this polynomial using synthetic division. So I'm going to use synthetic division to break down my cubic. And then hopefully we'll get something that will be able to factor and simplify this fraction a little bit. So using my calculator, what I did was I found 1 0. And I just did that by using the 0 option on my calculator and finding where that was crossing the x-axis. So I saw that over here, it looked like that probably wouldn't be a nice integer. Over here probably wasn't a nice integer, but I did notice that when I did use my 0 option here, and I found my bounds, that gave me a 0 of x is equal to 2. So I know that I can use that value to break down my polynomial. So I'm going to put the 2 on the outside, put my coefficients here. So 1, -1, -5, and +6. Perform my synthetic division, which gave me a remainder of 0. So I do know that 2 is obviously a 0. So this is telling me that since x is equal to 2 is a 0, my corresponding factor would be x minus 2. And the rest of my polynomial, once I break that down, would go from a cubic down to a quadratic. So what I'm going to go ahead and do in the numerator is now I know I have a factor of x minus 2, and I know I have this factor of x squared plus x minus 3. So I'll make this f prime of 2 equal to the limit as x is approaching 2 of x minus 2 times the quantity of x squared plus x minus 3 all over x minus 2, which works out nicely for us because now we notice that there is a factor in the numerator and the denominator that is in common, so we can go ahead and get rid of that. So I'm left with the limit as x is approaching 2 of x squared plus x minus 3, which at this point, if I go and substitute in using direct substitution, this is going to get me a value. It's not going to give me any undefines anywhere, so I'm going to go ahead and do that. So 2 squared plus 2 minus 3 is equal to 3, which we were saying in the last problem, once we get this thing at the end, that is representing the slope of our tangent line. And at this point, that would be at the x value of 2. So it's also asking us to write the equation of the tangent line. So now that we have the slope, we have a point that we started with up in the top. So my slope is 3. My point is 2, 0. I'm going to use my point slope form. So y minus 0 is equal to 3 times x minus 2. I'm just going to clean that 0 up a little bit. So y is equal to 3 times x minus 2. You can leave it like this. If you want to distribute and make that y is equal to 3x minus 6, that's totally okay. All right, so our last question has to do with interpreting a derivative. So we said that the derivative is really just a rate of change. It really is representing just a slope. So when we're interpreting that, we have to keep that in the back of our mind. So we're told that the number of bacteria after t hours is n is equal to f of t. I want to know what the meaning is of f prime of 5. So f prime of 5 is just a rate. It is a rate of growth. And I know it's growth because we're talking about a positive value here. So is the rate of growth, I'm going to say specifically of the bacteria population. And the 5 is representing the t value. So here we're saying that that's going to be the growth rate at a specific time of 5 hours. And if we're talking about a rate, then our units would be bacteria per hour. So if we're talking about a rate of growth, that would be bacteria per hour. So if you want to write it out in words, that's what it would look like. If you want to write it out as bacteria with the slash hours, that's fine too. All right, so suppose there's an unlimited amount of space and nutrients for the bacteria. Which do you think is going to be larger, f prime of 5 or f prime of 10? So remember that these 5 and 10 represent the number of hours. So if we are unlimited, I would probably say that f prime of 10 would be larger, because if the bacteria is going to keep on growing, then the amount after 10 hours would be larger than that after 5 hours. So f prime of 10 would probably be larger than f prime of 5, since the bacteria would thrive in that environment. And we should be able to kind of conclude that f prime of any time value should increase as time increases. But if we were talking about a limited amount of space, the bacteria population probably isn't going to keep on growing if we run out of space at some point. So it really depends on kind of what the growth area would be. So I'm going to say the growth rate would slow down at some point. I don't know what that would be. So I would say that maybe f prime of 10 might be less than f prime of 5. Because if we run out of space before we reach f prime of 10, then the bacteria rate might be larger at f prime of 5. It really just depends on kind of what that area would be where the bacteria are growing. So what does the statement f prime of 5 is equal to 120 mean? Well, here's my time, here's my rate. So I would say the rate of growth of bacteria at the instant of t is equal to 5 hours, because remember that we're talking about the instantaneous rate of change. So at that specific moment in time is increasing. And again, we're increasing because that number is positive. That's positive. At a rate of 120 bacteria per hour. All right, so now it's your turn to do some homework. Please let me know if you have any questions on any of this.